Hi, Stuart here, and today we're going to talk about things that every team should do before they start actually trying to deliver a cloud project. This list also applies to any large enterprise project, but I'm a cloud person, so most of my enterprise projects these days are in the cloud. It's surprising when I go and do reviews of dysfunctional projects. And I go and talk to the people delivering them, the actual engineers, developers, and QAs. How many of them don't seem to have a grasp of the basic of these really important patterns that are sort of universal glue in all projects that are successful? And I have videos on each of these topics. In fact, I have a master class in some of them. And you can go check out my other videos. But if you're on a cloud project or you're going to start a cloud project and you look at some of these and you either don't know what they are, or maybe you're a little fuzzy because it's been a while since you've been an undergraduate, or these things happened after you went to school, you should probably refamiliarize yourself with them. And when I look at dysfunctional projects that are dysfunctional, not necessarily for process reasons, but because they have security, stability, and reliability issues, it's evident when I go look at the code and the system design that a lot of these concepts weren't followed. I have a whole video series on 12-factor net you can go look at. There is a lot of new thinking that's coming out about solid. If you think about the solid principles, they devolve to trying to drive low coupling but high cohesion. You can simplify your understanding of solid by understanding cohesion and coupling. As far as I can tell, there aren't any tools that let you compute what is solid, but there are well-known algorithms for computing cohesion and coupling from source code. So at the end of the day, what solid is good for is to put cohesion and coupling principles in a language that developers and testers and architects can understand. And then the tooling will help you measure cohesion and coupling, which you should do constantly. And the result will be better code, which will mean better systems, which will mean better cloud delivery. Domain-driven design is particularly important as a concept, especially the larger your system is going to be. Domain-driven design concepts help drive down complexity, which is the ruination of many cloud projects, and at the same time make sure that your software obeys the O, principle and solid. Yagni is about discipline. Don't add anything you don't need. And successful cloud projects are built as distributed architectures. And distributed architectures leverage some of the concepts from queue intermediating and microservices. And the degree to which your specific project needs those things is going to vary. But you should know them and know when to apply them, and more importantly, know when not to apply them. And lastly, accountability. No project of any kind, whether it's software engineering or not, succeeds without accountability. Teams, individuals, management, the business, they all have to be accountable. And the use of RACI matrices, RACI matrices, and Six Sigma principles, and ITEF principles are all part of expressing the same idea of accountability, but also clarity on who is responsible for what, because you cannot have accountability without clarity. So day one, man, I can't begin to tell you the number of projects I've seen that started with a POC, they showed it to the business said, wow, this is excellent. When can we have a production version of this? If there's one anti-pattern that I want to have stuck in your brain by the end of my presentation, in my opinion, this is an editorial, it's this. Therein lies the path to failure. POC code isn't designed to obey non-functional requirements, to scale, to be a good citizen in the cloud, to obey DevSecOps principles, to do anything else but to show the business that something is possible and what that possibility might look like. In the same way that painters often make sketches of different kinds about something they intend to paint. That is, almost all disciplined painters do this, by the way. Then you can think of a POC as a preparation to define a set of ideas and principles and business goals, otherwise known as functional and non-functional requirements. And then you really should start the project off in a disciplined way, which means that before the first stick of real code that's written and delivered to an environment that eventually will end up in production, you should have DevSecOps. It is probably the single biggest driver to success, is that you have these things in place before you start scaling up the number of project teams. Because the definition of your process, procedures, and awareness as expressed through DevSecOps pipelines and the accompanying wikis are the principles by which you will operate and deliver your project. And without them, you are doomed. So, day one, you want continuous integration, continuous deployment, continuous configuration. You want the ability to stand up and tear down environments, and you want the ability and the discipline to exert continuous management. We'll talk about that more in a bit. And then you need to get serious about security on the first day. And these are some of the activities, not inclusive, but some of the activities that you should absolutely have. And on the slide, from a couple of different sources, we have the DevSecOps infinity loop, because this is a constant and never-ending process to achieve constant and never-ending improvement, otherwise known as sustained engineering. So let's just start with anti-patterns that will kill your cloud project. And I'll start out by saying, go see the previous slide. If you're not doing that, you're already in trouble. When I look at projects that have gone off the rails, which I spend a fair amount of time doing now, there is this pernicious behavior that means that there is insufficient policy, procedure, and awareness on your project with accountability. And that assumption is that something, doesn't matter what it is somebody else's problem, which is fine if you check that it's being done and that the humans that are doing it are doing it competently, that is, in harmony with the philosophy of the entire project, e.g., the business goals as expressed by the functional and non-functional requirements. For example, disaster recovery. I'm sure somebody in DevOps is doing disaster recovery. And then you go talk to compliance and you say, do we have any rules around that? And they say, oh, sure. And you say, well, who have you shared those rules with? And they say, you're the first team that's asked. And we go, uh-oh. By the way, a DR system that you don't regularly exercise is like making backups without testing whether or not you can restore them and what you backed up is still there when you restore it. It's an empty gesture, or as I like to call them, SPI, suicidal project ideation. At the management level, if you look at projects as a pyramid, and good projects are a pyramid, somewhere around layer 3 or layer 2, there should be this ongoing discussion with a matrix of roles and responsibilities that encompass the functional and non-functional requirements, which include things like DR. And you should have a team associated with that and a human on that team that's ultimately responsible. Here's my next pet peeve. In some ways, it's too convenient. It's too easy to deploy the things that developers need in order to achieve the business requirements, right? The business says, I've got this set of requirements. The engineers say, great. Well, let's see, we're going to need a web API. We're going to need a database. I'm going to need some functions as workers. I'm going to need a queue, place to put secrets and configuration. I need this. I need that. I need the next thing. Those are all good, right? That's good. Engineers should be doing that. But where do those things live? They live on a network. And unless you start your project with a network design designed for growth in the likely directions your project is going to grow, e.g., if your project is going to eventually be globe spanning, multi-region, then you need to have a network design that accounts for that. If your project is going to have tenants, that's a SaaS project of some kind, then you need to have a network that allows you to exert tenant isolation. If you're going to have a project that is going to span different types of data centers, so a hybrid project, you need to have a network that accounts for that. And the kind of network you have and the assumptions that are made in designing, documenting, and implementing that network shouldn't be a secret, because developers and engineers need to actually understand the constraints of the network you're built so that they understand architecturally what they need to do to accommodate that. They need to be able to say, look, I've got these use cases from the business, and based on our best estimation of how we need to architect, design, and implement this, we're going to have problems here, and possibly here on the network in terms of being able to get from place A to place B, which we need to do, or getting enough throughput, or having sufficiently small latency so that we don't have problems. You just can't go into a project and start spewing out infrastructure. Again, the great thing about clouds is it's really easy to do. The bad thing about clouds is it's really easy to do without having to consider the network. Because in many cases, the cloud provider will just stand up a default network. But it may not suit your InfoSec folks. It may not suit the architects on the project. And in the end, those things will result in it not suiting the business, and that's bad. Good networks are built with defense and depth in mind. And good networks have observability. In order to genuinely have observability, you need to actually have observers. But networks and large cloud systems in general produce a torrent of data. And what you need, and what you generally have to pay for, is a system or systems capable of sorting the wheat from the chaff, so that at different levels of administration throughout the project, you can do management by exception. You can know what things are trending in a bad direction, or what things have been validated or are problematic, and you can go and manage those things. There was a really great ad for IBM. The ad was quite funny, but the thrust of the ad is that security and quality are not pixie dust that you can sprinkle over a project at the end. We're going to go to production tomorrow, and we'll have 10,000 users by 9 a.m. Quick, let's go put some security and quality on the project just to make sure. No, that's an anti-pattern. You need to really have policy, procedure, and awareness that enforces separation of duties. You need to make sure you have automation so you don't have to be generous for privilege. You just can't allow substandard anything to flow into environments, because what you start doing from the first day is building a corrosive and never fixed puddle of technical debt that becomes an ocean, and your system becomes an island, and then the waves wash over it and it is gone forever. Surprising how many projects die from entropy long before their estimated end project life. Software projects are well-designed. Software projects express the lifetime and intent of the project And they also have the criteria by which the project will be made end of life and eventually replaced by something else, or potentially not. And what cuts that well-crafted, well-honed, well-thought-out plan short is cutting corners in these 4 areas. Don't put process ahead of business goals. You have to look at the overhead in your projects. And overhead is defined as, if there are 8 working hours in a day, how many of those hours do people at different tiers in the pyramid spend on overhead tasks? That is, not delivering business value or validating that business value has indeed been delivered to the required quality bar at the required tempo. And if the aggregate overhead is 10% of your project or more, your project is probably doomed. So the temptation is, when things start going wrong, because if you go to management school, they teach you that if you are managing something and it's going badly, then what you need to do is have an infinite number of meetings to talk about why it's gone bad. And that is equivalent to trying to put duct tape on a broken window of a car that is not sinking into a lake, that's already sunk into a lake, to try to keep the water out after the car is filled with water. Automate your way out of dysfunction. And sometimes that means getting rid of dysfunctional humans. And that is a kindness in disguise, because pieces of your human capital that add dysfunction to your project or won't focus on the goal will probably benefit by joining the economic opportunity pool, allowing the rest of your project team to carry on to success. The thing that has been consistent throughout my career, and I'm now old and have seen computing go from punch cards to the cloud in my lifetime, hands-on as a developer, is be wary of the fad of the moment. And the fancier the process, procedures, and awareness are in an unautomated way, that is, we're going to have a meeting about this, right? The definition of failure is we have had to had more than one meeting about something. These things exist so that the people who should be accountable can play musical chairs or have an excuse because they had so much process that no reasonable human being could have followed it, and thus they are not held accountable for failure. Mature, responsible, and accountable teams can ship continuously using the Kanban or Lean philosophies, whichever one you like better, that works, here's the key word, works for your project. Again, that means we're delivering business value at the required quality bar on tempo. That is a certain amount of value per increment of time. This has shown up a lot in my thoughts over the years on YouTube, and I will keep saying it until I can get everyone to start believing it and doing it. Person with one watch knows what time it is. One with two is never sure. Which means a place for everything and everything in its place. Does that sound familiar? Like your mom, your dad, your uncle, your first boss? Mise en place, if you're a chef. So there are some basic rules for this. Rule number 1 is if it's not in the lifecycle management tool, it doesn't exist. So if it's not an ADO or Jira or whatever, I don't care what your tool is. The tool choice is not nearly as important as using the tool and keeping the data in it up to date. So if people are assigned tasks, we know what the status of the task is. They're putting notes in about their tasks. We know when the task is likely to be done. And when the task is done, we know how much actual effort it took to do the task. So we can get better at estimating the same sort of task next time. Have a wiki that everybody can update, and update it often. And be suspicious of stale pages. Successful projects actually go through and drag their documentation and call out to somebody, generally in the compliance organization, that these pages haven't changed for more than X number of days, which means either that the components and or processes involved are good and stable and they don't need to change, in which case you should update the page and say, nope, this is still true, in a note at the bottom, thus updating the change date of the page so it won't come to anyone's attention for another X days. Or they should go and find the people who are accountable to maintain those pages and remind them that they're not done delivering until they have updated their documentation. And third, and it may not sound like a place for everything and everything in its place, but it so is that you have to have a mechanism for detecting breaking changes in libraries, functions, APIs, messages, datagrams. People don't think about versioning data. Can't tell you how important that is for a large project with lots of different kinds of data, especially if we're exchanging data from different silos in the organization. Silos aren't always bad, right? Sometimes we have silos because we have separation of duties, or we have security boundaries, right? Or we have trust boundaries, or we have other reasons. Silos are not necessarily bad. Silos that don't have a functional collaboration process are bad, but a silo is not necessarily bad in itself. And thus, if we're going to have the ability to detect breaking changes, we need a way to articulate them. And the civilized development world has settled on semantic versioning, which is not perfect, but it fulfills the criteria of the Pareto rule, in which it meets 80% of our needs 80% of the time, assuming everybody follows the rule. And I have a whole YouTube on versioning. Complexity is a project killer. And here's where silos not having functional collaboration with each other are a problem. Because there's this temptation that comes with teams that don't have discipline or exhibit other less than salutary emotional characteristics, to be attracted to the shiny new thing. Shiny new things are attractive, but we are people, not magpies. If we already have a perfectly good relational database system that does what we need and follows the Pareto rule, adding a second one is probably not a good thing, because we have then diluted the pool of humans that can interoperate with it and get the best results from it. Adding a third one is cray-cray, which is not to say that everything has to be on a single platform or operating system or whatever, but for each of the different enterprise components. And if you're wondering what a good place is to look for enterprise components, I will direct you to the best book ever written, which is Patterns of Enterprise Application Architecture, which is in the Martin Fowler Library. And they make an enumeration of the various kinds of enterprise project components. And there's always this argument where this team comes to you and says, oh, well, we looked at the shop standard one and there's this shiny one over here. We've already started using it and we're almost ready to go to production. So we just need an exception kind of temporarily. Would that be okay? And the answer should be no. Bad development. The cold slide to failure is the iced over corpses of deviations. It's one of my favorite quotes. And I'll remind you again that if you look in the Patterns of Enterprise Application Architecture book and all of the other good books on that, various topics that fill up my bookshelf, and I have a published list of my favorite books. You can go look on my LinkedIn. I'll point out that those patterns exist for a reason, and that being the ability to scale out is the sign of a good implementation, and the inability to scale out is the sign of a bad one. I've debated whether or not to talk about this, but I have to, because the world is a way more litigious and complicated place, and the days where we trusted open source projects with good reputations, and we trusted them to be maintained, and we trusted them to be open, so that if we found a problem or suggested an enhancement, that we could report the problem or do a pull request for the enhancement, and they would, the community would be strong. And there are projects like that, right? Projects I love. .NET, C#, Redis, lots of other things like that. But it's complicated because open source licensing is really tricky. Most of you watching this video are going to be engineers and architects like me, developers. People ask me what I do. I say I'm a developer. So we really have this obligation to run it by whoever you got to run it by to make sure that the licensing conditions are something that you can use. It's really tempting as a developer to be looking in NPM or GitHub or NuGet or whatever and go, ooh, I know that those guys make really sweet components or libraries or whatever, and I trust them, and they have a good reputation, and look how many people have forked this or downloaded it or used it. So it has popularity, and that used to be a good sign of reputation. And it still is, but, two things. As open source libraries and tools and stuff become bigger and bigger, it becomes harder and harder to know if it's safe. And bigger and bigger is not always in the source base itself, but in the number of references it then references. So you're referencing it, and it's referencing 72 other things. Well, those things could have evil lurking within them, and they just haven't had time to go and double and triple check that. And the other thing is that just because something is awesome sauce doesn't mean it's bug-free. I love OpenSSL. Every major software company on earth that has to do internet-based anything pretty much uses OpenSSL. And that was great, and everybody trusted it, and everybody loves it, and I still love it, and I still use it. But Heartbleed came along, and all of us react like a man being mugged in a meadow. Now, to their credit, the entire community that supported OpenSSL jumped on it. They came out with a patch. They did everything in their power to communicate to everyone that you should stop using this version and start using one of these versions. They added a lot of tests to prove that Heartbleed was no longer a vulnerability. I'm just saying, bugs happen, even in the most reliable places. So trust but verify, and it's not a one and done deal. That means you need a tool like Mend that every time you build your software also scans all your dependencies. And if there are problems or whatever, a lot of these companies like Mend, they have this huge metabase of known software vulnerabilities at specific versions on specific platforms. And they can tell you, they'll go, you know what? This thing has this vulnerability. And then they'll go on and say, but we know it's fixed in this version. So if you just upgrade the version, it'll be fine, at least as far as we know. And that's the only thing anyone can promise you, at least as far as they know. And you have to insist that the teams upgrade vulnerable or outdated components. You have to have a budget to prevent technical debt, and you have to insist that teams use it. You're not going to ship this additional feature. You're going to go through and fix all your references to be up to date. You're going to fix all of the code flaws that we found using our favorite tool like Checkmarks or Veracode or whatever, or SonarQube, which is a great piece of software. And you're just not going to be allowed to ship any more stuff until you do. And that requires management buy-in at the top of the pyramid that the business is vulnerable if we don't keep fixing things. Sometimes it's good to have a throat to choke. And I have seen big companies get requests for software and then automatically buy the support package as kind of an insurance policy. And usually it entitles them to free upgrades or whatever. I mean, there's perks. But they don't usually track whether or not they're getting value for money, or indeed whether the thing that got purchased last year is still in use this year. So you need to have an OODA loop, and you need to close that OODA loop and make sure that you're doing all these things continuously. Because sustained engineering is about the continuous execution of validated processes. At best, a manual process is the proof of concept for automation. We know we need to do this, and this. We wrote it all down. That becomes a requirement. We give it to the automation team, and they grind it out, and then they come up with tests for it, and then we, the people who asked for it, validate that it worked. And a process that's not automated is a risk. And if you get enough of them, your project will fail. And if you're going to have automation, you damn well better have telemetry. Telemetry of any kind is absolutely useless if nobody looks at it. If you have logging from applications or performance data from your hosts and no one looks at it, then you have the appearance of doing the right thing without actually having the accountability of having done the right thing. And so, again, full circle continuous delivery via process, procedure, and awareness with validations. This is always a tough one. And I've been in a lot of discussions with very smart people and have heard all kinds of arguments about how many environments do you need. There is a trade-off because environments cost money. If you're lucky, tearing down and bringing up environments is really easy. And if you're super thorough, you should be able to destroy an environment and put it back in a very short space of time. Less than half a day, ideally, so that you can start tabula rasa and then provision and deploy things and have a set of automation that validates that everything's working and that the business functionality is being delivered. You need to understand viscerally, not just the DevOps people, but the developer who are going to be writing code that's going to require more configuration and more components, and those components will have secrets, right? Viscerally, you need to understand when I need to add something new and it has new configuration or new secrets or new settings or new whatever you want to call it. Anything that varies by environment, that those things should be tightly controlled, well understood, and consistently documented. By the way, just because it's in a wiki doesn't mean a human wrote the page. I'm on a project now, and about a third of our pages are actually generated out of the metadata that our project produces. And the wiki pages, along with dashboards and reports and things, which are all sort of bundled together so that we're all in one shop stop, they are used to make sure that the as-built is always represented in the documentation. And then lastly, minimum privilege and separation of duties. The number of humans that can change environments without the use of automation should be vanishingly small. And you do need those humans because bad things happen. And if you have a production outage, you need operators that have the discipline to do the right thing incrementally, to push back against the business screaming to bring the system back up, and making sure that in the process of making it right, they don't make it wrong. So Moliere, it's a really great quote from Moliere. It's not just what we do, but what we do not do, for which we are accountable. And so there are human components of successful cloud projects. I used to joke when I was a lot younger that there was nothing wrong with my software projects that getting rid of all the people wouldn't fix. I'm not wrong, it's just not possible. I kept hoping I could just sit there and command the computer to do what I want all by my lonesome. But in fact, successful projects are built by few smart people rather than an army of less capable ones. And that there are certain personality traits and project traits that are non-negotiable for success. Honesty, integrity, transparency, knowledge, training, and technology, pacing, tempo, and timing, attention to detail, with the ability to bring the whole into your brain. That's the sign of a good architect. And a good architect is a synthesis, first and foremost. They understand at all levels of granularity how things fit into the whole, at least for the subsystems they know, and they're capable of communicating with their peers who understand other pieces and coming to a group consensus on how the system operates really. I can't stress an overwhelming urge to minimalism. Mies van der Rohe coined it perfectly, less is more. Lots of thought leaders in philosophy, technology, and management have said there is no substitute for discipline, because there isn't. Thank you for your kind attention.